Hello everyone. I will explain how to perform the experiment, but before that, I would like to ask some questions to you to check your previous knowledge. Everyone present over here, have you seen the motion of the pendulum of the clock? Have you seen the motion of seesaw? Have you seen the motion of sewing machines, needle? Have you seen the motion of the pedal of the sewing machine? What kind of motions are these? Yes, yes, to and fro motions. Very good. Yes, so that is up and down motion. So whenever you see such type of motions in your everyday life, you can say that such motions are called as simple harmonic motion. Now, in such motions, the object covers the same path again and again. That means its motion going to repeat over the same path, over the fixed interval of time. When the motion gets repeated over the same path, over the same interval of time, then you can say that the motion is called periodic motion. Okay, so can you give the examples of periodic motions in your everyday life? Yes, yes. The motion of the fan. Yes, the motion of the fan is periodic motion because the blades of the fan are going to repeat its positions again and again over the fixed interval of time, so that it is periodic motion. Is it so? Is every periodic motion is a simple harmonic motions? No. Yes. Very good. No, because circular motion, the motion of fan, it is the example of circular motion, and in that case the motion is going to repeat, so it is periodic motion, but it is not a simple harmonic because it is not a to and fro motion. When it is not to and fro motion, then it is not simple harmonic motions. So every periodic motion need not to be a simple harmonic motion, but every simple harmonic motions are periodic motion. So now today we are going to perform the experiment of simple pendulum and to calculate its time period. For that, the today's our aim of experiment is to calculate the time period of simple pendulum. What are the apparatus required for that? We need iron stand, we need a retor stand, we need a stopwatch, we need a thread about 1 meter, we need metal bob, These are the apparatus we require to perform the simple pendulum. What formula we are using here to calculate the time of period of simple pendulum? That is, the formula is T equals to time taken divided by number of oscillations. Number of oscillations. So the diagram for this experiment is, suppose this is a iron stand, and this is the thread which is about 1 meter. So this is the thread, and this is what the rigid support. This is the point of suspension. So this maximum distance is called as the amplitude. This is called as the mean position. And this is called as the extreme position. Means the maximum distance covered by this pendulum or the bob of the metal on either sides of its mean position is called as the extreme positions. So this is the maximum point on either sides of the bob of the pendulum from mean position. It is called extreme positions, and the distance, which is maximum distance covered by the pendulum from its mean positions on either sides, it is called as the amplitude. So now in that case, we are just displacing this bob of pendulum so that it will execute the simple harmonic motion. That means it will execute the to and fro motion, and this to and fro motion is nothing but the simple harmonic motion. So this is what the length of the thread. This is what the length of the thread. Okay. Now just see that how the simple pendulum you can construct. See here. So suppose this is the rigid support. That thread is supported by the rigid stand, and its one end is connected with the thread, and free end of the thread is connected with the metal bob. This metal bob you can take of any size, but I will prefer to take the bob of pendulum in circular shape because it has a symmetry from the center of the circular part of this metal bob, and its resistance to the air will reduce as compared to the when you are taking the uh, uh, rectangular shape or any shape, cone shape, it will the more it will having the more resistance by the air. So I will prefer to use the pendulum of circular shape. So now this is what the pendulum, and this is what the mean position, because it is a rest position, it is called as the mean position. Now we have to make the arrangement of the pendulum like that. Then we have to take the pendulum at any one end, keeping in mind that ensure that the thread of the pendulum should be tight. Then release the bob of the pendulum so that it will execute the motion. So this motion is called as simple harmonic motions. So now this motion is called a simple harmonic motion, and this bob of the pendulum completing some oscillations or vibrations. So these vibrations are oscillations which depends on the thread of length of the thread we are using for this experiment, or using for the constructing the simple pendulum. So this is the thread of the pendulum, and this is the bob of the pendulum, metal bob. It is a mean position. You have to take the bob of the pendulum at one place. You have to displace it, and after that, while displacing the pendulum from its mean position, you make sure that the thread should be tight. Okay, and you have to now release the bob of the pendulum so that it will execute the simple harmonic motion, and its motion is going to repeat, so that it is periodic motions. Now one oscillation means from here. Okay, just you have to, when the bob of the pendulum crosses the mean position, you have to start your stopwatch. You have to start your stopwatch, and then it will go here to the extreme position, then again go return to the mean position. Again on the other side it will go to the extreme position, and it will again cross the mean position. So this is called as the oscillation one oscillation from here to here, again here, and again here, and again here. This is the one oscillation. Or you can take that one oscillation is like that. Suppose it is from here, it is started from here, and again here, here one. Suppose here to here one. You can take according to your convenient way. Okay, so you have to take the observations for the 20 oscillations minimum. You can take the oscillations up to 30 also. You can take the oscillations up to 10. So here we are going to take the number of oscillations 20. So you have to start the stopwatch, and after completing the 20 oscillation, you have to stop the stopwatch, and you have to observe the time taken by the pendulum for the 20 oscillations. So we are having the tabular observations during the experiment. So the observation table time taken by pendulum for 20 oscillations in second, and here time of, or you can say time period of pendulum in second. So you have to take at least 5 observations. So for 1, 2, 3, 4, 5, and you have to write your observations in an observation table. So first of all, you are taking the 20 oscillations, and the time taken for the 20 oscillations is, suppose we are getting 31 seconds. 31 seconds. Next, we are taking the 20 oscillations, and time for the 20 oscillations taken by pendulum is 32, then 33, then 34, and then 35 seconds. Then you know that the formula for calculating the time period is time taken divided by number of oscillations. So here you can make the calculation. First, time period equals to time taken divided by number of oscillations. That is t equals to 31 by time taken is 31 divided by 31 is the time taken by the pendulum for completing the 20 oscillations. Here divided by number of oscillations you are taking 20. Suppose you are taking the number of oscillations 10, then it will be in divide number of oscillations will be 10. If you are taking the number of oscillations 30, then it will be 30 in place of 20, like that. So when you will calculate it, it will comes out to be 1 point. Calculate it, 31 divided by 21. 21 is 20. 3, 1 minus 0, 1. 3 minus 2, 1. So it is point, decimal point 101. 1.25, 1.55 seconds. Second calculation is equal to t equals to time taken is 32 divided by number of oscillations 20. It will be 1.60 seconds. Third, it will be t equals to 33 divided by 20 equals to, yes, 33 divided by 20, how many? It is equal to the 1.65 seconds. Next, t is equals to 34 divided by 20 is equals to 1.70 seconds. 5, t equals to 35 divided by 20 equals to 1.75 seconds. So these are the observations, and these are the time periods we are calculating from this tabular form. We are sorry, first one is 1.55, second one is 1.60, third one is 1.65, 1.65, fourth one is 1.70, and last one is 1.75 seconds. 1.75 seconds. So these are the observation table, and now we have to calculate the average time period. Average time period. Then we will get the time period of the simple pendulum. So average time period will be equals to average time period. Average time period, it is equal to the average of all the observations. So it is t equals to 1.55 plus 1.60 plus 1.65 plus 1.70 plus 1.75 divided by. So how many number of observations are there? 1, 2, 3, 4, 5. So it is divided by 5. It will comes out to be. Comes out to be. See here. 5 plus 0, 0. 5 plus 5, 10. 10 plus 0, 0. 10 plus 5, 15. So it is 15 means 5. Carry 1. 7 plus 1, 8. 8. 8 plus 7, 15. 15 plus 6, 21. 21 plus 6, 27. 27 plus 5, 32. 32. Carry 3. 3 plus 1, 4. 5, 6, 7, 8. 8.25. 8.25 divided by 5. So it will be equals to 5 1 ja 5, 5 6 ja 30, and 5 5 ja 25 seconds. So your time period for this pendulum for 20 oscillations, this time period, and for the time period of one oscillation, it is equal to 1.65 seconds. This is the time period of your simple pendulum. Okay, so it is very easy to calculate. Okay, now the main interesting things about the simple pendulum is this time period of simple pendulum. Time period of the simple pendulum, it does not depends on the size, the material of the pendulum, size, shape and material of the pendulum. This time period is only depends on time period is independent of shape, size and type of material. Type of material of the bob of pendulum. It's only dependent on length of the string or the thread. And its relation between T is directly proportional to the under root of L and inversely proportional to the under root of G. That is, G is the acceleration due to gravity. So this is the L is the length of the string you are using in the simple pendulum, and under root G is the G is the acceleration due to gravity, under root of acceleration due to gravity, and it is under root of length of the string. So time period is always directly proportional to the length of the under square root of the length of the pendulum, and inversely proportional to the square root of the acceleration due to gravity. That means if you increase the length of the string of the pendulum, time period will increase. And if you will decrease the acceleration due to gravity, the time period of the simple pendulum will be increase. So on the moon, we know that acceleration due to gravity value is very less. So as compared to the earth, the motion having then the period of pendulum will be more on the moon as compared to the earth. Again, okay, so these are the observations and these are the time periods we are calculated here. And next one is the you can take result. What result we are getting here? The result we are getting here, the average time period of simple pendulum is 1.65 seconds. And what are the conclusion we are getting here? Conclusion, the time is period is independent of shape, size and type of material of the bob, and it depends on only length of the string or the thread we are using for the simple pendulum. Okay, these are the important points in this experiment. And one more thing is the precautions. The precautions that are the precautions are the thread of the pendulum should be tight. To get such videos, subscribe the channel and set it on the all button. Share and like with your friends. Thank you for watching.